Okay. Here's Laney. Here's Laney. Okay. All right, here we go. How many ways can I arrange 7 books in a row? Well, I heard somebody give the answer. What's the setup? What work are you going to show? 7 factorial. That's exactly right. 7 factorial. So then let's all type that in. Make sure everybody knows how to use that button. 7 factorial. I heard somebody say 5,040. Is that the right number? 7 factorial. Okay? How many ways can I choose a committee of 6 from a group of 10 people? Okay? Now, we are choosing 6 out of 10. That setup is always going to be either a P problem or a C problem. All right, so when you have a group and you're going to choose some from the group, that's a P or a C. So in this problem, we're picking a committee of 6. If I put you on the committee, does it matter if you're picked first, second, third, or whatever? No. So this would be 10C6. 10C6. So number 2, there are 10 people. I am choosing 6 of them, and the order doesn't matter. So that's a combination. So let's all type this in, make sure we can.
What's the C mean?
Combination. Means order does not matter. So 10 math over to over to prob and down to NCR 6. Did you get 210? So we're going to type all these in, like I said, but we'll do a couple of them just to make sure you're getting the right numbers. So this is the work. This is all the work, and then that's the answer.
Wait, I get
All right, how many outfits are possible if I have 10 shirts and 11 jumpers? That's almost exactly like one from our notes. Who remembers how to do that? We have seats? Oh no, here, you can sit in his, he's in the back now, so you can sit there.
Just get 10 times 11?
It would be 10 times 11, that's exactly right. I can pick a jumper 10 ways and a shirt 11 ways, or vice versa, it doesn't matter. So that would just be 10 times 11. I need to pick a shirt and I have 10 choices, and I need to pick a jumper and I have 11 choices. So that is just 10 times 11. Now, sometimes we're tempted to throw factorials in there. Factorials are only used if you're arranging things, okay? Don't put, I'm picking. I have 10 choices and I have 11 choices. I'm not arranging my shirts and jumpers. All right, how many ways can I award a pencil eraser calculator to a group of 8 students? You've got to visualize what's going on here. I have a group of 8 students, and what am I going to do? I'm going to pick 3 of them, right? So that's either going to be 8P3 or 8C3. I hear some P's and I hear some C's. What are the arguments for both? I mean, why are we saying P or why are we saying C? It's a P because the prizes are different. Put yourself in this situation, guys. I walk in and I say, okay, One of you is gonna get a pencil, one of you is gonna get an eraser, and one of you is gonna get a calculator. Do you care where you get picked? I mean, if you're smart, you care, because wouldn't you rather me give you a calculator than a pencil? Order matters. Because if I pick you first, you get one prize, and if I pick you second, you get another prize. Order matters. Now, what if I were giving, so the answer to the question is 8P3. That's the answer. But what if I had the same 8 kids, and I was giving away 3 pencils? I'm going to pick you, and everybody's getting a pencil. What would that be? 8C3. That would be C. Because if you're getting the same prize as you, does it matter who I pick first? No. See the difference? If you're getting picked for a specific job, a specific present, a specific prize, it's a P. But if you're just getting picked and you're all getting the same thing, then it doesn't matter if you're picked first, second, or third. All right, so 4 was 8P3. What's 8P3? 336. Yep, 336 is that one, number 4. All right, how many ways can you arrange the letters of I love you? 1, 2, 3, 4, 5, 6, 7, 8 letters. So we start with 8 factorial. Then what do we have to double check? Are there any repeats? Oh, there are. There's an O here and an O here. So I divide by 2 factorial because there's 2 O's. Are there any others? That's it. So my answer is 8 factorial divided by 2 factorial. So I can type that in. And it's 20,160. That's what you should have gotten as your answer. Now, on this particular quiz, a little bonus question. Let's see if we can do that. How many committees of 3 boys and 2 girls can be chosen from a class with 6 boys and 10 girls? All right, so think about that for a second. I got a group of 6 boys over here and 10 girls. And I'm going to pick some from both. Now, it's a committee. Does order matter when I pick members of a committee? Not a committee. If I'm picking a president, a vice president, and treasurer, that matters. But if I'm just picking you to be on the committee, it doesn't matter. So I need to pick 3 boys out of this pile right here. And the order I pick them doesn't matter. So what will that look like? 6C3. There you go. There's your boys. 6-3C. Boys done. Now what I want to do with the girls, I want to pick 2 out of here. Well, it's always the number you start with. Your calculator won't let you do it in the other order, so you'll catch that. But it's always, this number is always how many you have to pick from, and then this number is how many you are actually picking. So this will be a number, and this will be a number. Any ideas what I do with these 2 numbers? Multiply them. I multiply them because I am picking boys and girls. If I were picking boys or girls, I would add. The and means multiply, and I want a committee with boys and girls on it. Okay? All right. Let's go ahead and type that one in, make sure we get the right answer there. And by the way, you can do each one separately and then multiply them, or you can do it all together. So I'm going to do it all together. I'm just going to say 6 NCR3 times 10 NCR2. And the answer is 900. So So if you got 900, you did it right. All right, let's turn the paper over. These, I am not going to calculate the answers. You can certainly if you want. These I'm just going to set up because we don't have time to type all these in. Well, let's see if we can get these set up. How many ways can I arrange the letters of I miss you? That's just like I love you. How many letters are there? 1, 2, 3, 4, 5, 6, 8. So I start with 8 factorial again. I got some duplicates though. I got a couple of S's. And I have a couple of I's. Is that it? Yep. So, huh?
Can you make it 4? Do they have to be different?
Since 2 factorial is 2, this is like 2 times 2, but if this had been a 3 and a 2, it would not be 6. So I would suggest that you just get in the habit of doing that factorials. Alright, factorials cannot be combined. Alright, so I'm going to go ahead and type that one in. I said I wasn't going to, but this one's a little different. So 8 factorial divided by parentheses. I got 10,080. All right, so now I'm going to make a cake. And I have to decide what flavor of cake I'm going to make. And I have to decide what kind of icing I'm going to put on it. This is exactly the same as me going to my closet and looking for a shirt and a jumper. Only this time I'm picking a cake and an icing. All right, so what's the answer going to be? You say 60? Well, you're exactly right, 60. Because there's 6 choices for cakes and 10 choices for icing, so there's 60 possible cakes that I could make. How many teams of 4 can be selected from a class of 10? So here's your 10 kids, and you're going to pick 4. Is that going to be a 10P4 or a 10C4? C. It's a C. Because I'm picking 4 people. Order doesn't matter. So the answer to number 3, very good, is 10C4. Number 4, how many ways can I arrange 6 people in a row? 6 factorial. If you are arranging people in a row, it's people factorial. So 8 people in a row, 8 factorial. 6 people in a row, 6 factorial. How many ways can I choose a president and a treasurer from my class of 22? So here are the 22 kids. I'm going to pick 2. Is it 22C2 or 22P2? It's a P, because the kids I am picking have different jobs. I'm not picking a committee. I'm assigning them specific jobs. So it's 22P2. How many 5-card hands contain 3 clubs and 2 red? All right, so let's think about this for a minute. I have my deck of cards, and I'm going to split it up, and I'm going to put my clubs right here. So here's my pile of clubs. Anybody know how many clubs there are in the deck altogether? 13. Basic probability often involves a deck of cards, so you probably should familiarize yourself a little bit with a deck of cards. I'm not asking you to become expert euchre players or anything like that, but just know the basics of a deck of cards. There's 52 cards in the deck, 52. They're divided up into 4 different kinds called suits. diamonds, hearts, clubs, and spades. So each of those suits has 13. 52 divided by 4, 13. Hearts and diamonds are red cards. Clubs and spades are black cards. So there's 26 reds, 26 blacks. Each of the hearts, for example, the 13 hearts, is different. You have a 2 and a 3 and a 4 and a 5, and you count all the way up and you get to 10. Then you have a jack, a queen, a king, and an ace. And that's true for the 13 hearts, the 13 diamonds, and so on. Okay. You can Google it if you're not sure. If you're still not sure, you certainly can get on there and Google it and know just the basics of it. Okay, so we're gonna pick 3 clubs. So here's my pile of clubs. There are 13 clubs, and I am going to pick 3 of them. Almost all card problems, and certainly every card problem we do in this class will be a C. We're building a hand, and we don't care what order we get them. I know there are some games, specific games, where order might come into the picture. We're not doing that. We're building a hand. So in my hand now, I'm going to have 3 clubs. There are 13 to pick from. I'm going to choose 3. What else do I need to pick? 2 red cards. All right, now remember, I split my deck up. How many of the cards are red? Half of them, 26. So 26 red cards, and I'm going to pick 2 of them. So 13 possible clubs, choosing 3. 26 possible reds, choosing 2. And I'm going to multiply those together because I am building a 5-card hand, 3 clubs, and 2 reds. And again, you can do those as separate problems, or you can do it all at once. I just like to do it all at once so I don't have to re-enter things. But it doesn't really matter. Your answer is 92,950.
Is it 26 because it says 2 red cards? Or
No, it's 26 red cards. The deck has 26 red cards in it. So there's 26 to pick from. And I have to pick 2 of those. All right, so main ideas, problems are all different. There's nothing we can do about that. Problems are all going to be different, but the main ideas. Whenever you have a bunch and you're picking a few, it's either going to be P or C. And you'll decide based on whether order is important or not. Okay? If you are arranging n things in a row, it's n factorial. Period. So 8 things in a row, 8 factorial. 15 people in a row, 15 factorial. If you have repeated or duplicate items, like in the word, when you say I miss you and there's 2 S's, you always handle duplications by dividing factorial. So if there's 2 S's, I divide by 2 factorial. If there's 3 I's, I divide by 3 factorial. Okay? All right. All right, so put that away, and let's get back to our notes. So the quiz, we're gonna talk about some other things today, but the quiz you take next time will have problems just like these. This is the kind of problems that are gonna be on your quiz. So even though we're talking about other things today, this is what your quiz is about. Everybody got that? Okay. All right, good. All right. Did everybody who came in late get one of these? Did I hand everybody one of these? Did you get one, Bert? Mandy, did you get one of these? Yeah. Practice quiz? Okay. You did get one of those? Okay. All right, so now let's get back to our notes. pick up where we left off, which was oh, yeah. Ready for 9.2 now. We're going to start 9.2. Okay? Now, to do 9.2, that first problem says x plus y to the fourth. That means x plus y times x plus y times x plus y times x plus y. So everybody in this room right now could do that problem by simply foiling and foiling and foiling. It would take a long time, or a while, but you could all do that. What I'm going to do today is show you a little shortcut that we're going to apply, believe it or not, to our study of probability. Okay? So here's how the shortcut works. Over to the side or somewhere, maybe on another sheet of paper, I need you to copy down what is called Pascal's triangle. Blaise Pascal was a great mathematician a long, long time ago. So here's what his triangle looks like. And later on, we might talk a little bit about where it came from. But we're going to have several rows of our triangle, and each one is going to start and end with a 1. So at the top, you just have a 1 and a 1. Now, the next row starts with a 1, ends with a 1, and then in the middle, I'm going to add these two together, and that's going to give me that number. So the second row is just 1, 2, 1. Now the third row starts with a 1, ends with a 1. But now to get these middle numbers, I'm going to add these and get 3, and add these and get 3. So what do you think this next row is going to be? I start with a 1, end with a 1, but what am I going to put here? 4, 6, 4. And now let's do one more. Start with a 1, end with a 1. It keeps getting wider. What will go here? 5. Okay? So we're building the triangle by simply adding the two numbers above it. So the next row, this is the last one I'm going to do here because I'm out of room on this side. But the next one will be 1, and then this will be a 6, and a 15, and a 20, and a 15, and a 6, and a 1 on the end. Now, what does that triangle have to do with this expansion, this problem right here? Well, if you are going to expand x plus y to the fourth, then the first thing I want you to do is go to the fourth row of your triangle. So here's the fourth row of the triangle, right here. And I want you to copy down those numbers. So you're going to copy down, I have to erase mine because I don't have any room, 1, 4, 6, 4, 1. And you're going to space it out. So it's going to go clear across your page there. So, step 1, whatever power I am raising it to, I'm going to go to that row of the triangle. Now, next to each of these numbers, I want you to put the two components of your binomial. So put an x and a y. And I think it's a good idea to get in the habit of putting them in parentheses. It won't really matter for this first problem, but it will for the others. So go ahead and get in the habit of putting your x and your y in parentheses. Okay? So fourth row of the triangle, copy down those numbers, and then next to each of the numbers, I put this and this. We're almost done, believe it or not. You're gonna have your answer here real quick. On this first X, right here, put that power, so put a 4 there. And then on every X, count down. So 4, 3, 2, 1, 0. And then on the Y's, go the other way. So 4, 3, 2, 1, 0. Put plus signs between each term and do any simplifying that you can do. So for example, here, y to the 0th is 1. Remember, anything to the 0 power is 1. So this first term is just x to the 4th. The next term, there's really nothing to do there, so it's just going to be 4x cubed y, 6x squared y squared, 4xy cubed. And here we can simplify, because again, anything to the 0 is 1, so that's just y to the 4th. And there's your answer. So that's a little shortcut if you need to raise something like x plus y to a power. And you don't want to FOIL. You could FOIL, but that would take a lot longer. All right, now let's look at the next one. We're going to do exactly the same steps, guys.
What's the answer?
That's the answer, right there. That's what you get if you FOIL it all out. Now, let's look at the next one. How do I start? Who can remember what I do to get started if I am going to find x plus 2y to the 3rd?
Look at the
Go
Pascal.
to the 3rd row of the triangle and write down the coefficients. So you've got your triangle there. I've used the 3rd row a lot, so I know it's 1, 3, 3, 1. All right, what's the next step? Okay, except it's not x and y this time, it's x and 2y. So x and 2y, parentheses, absolutely necessary. So I wrote down the 3rd row of numbers, and next to each of those numbers, I put an x and a 2y. Anybody remember the next step? Put the powers on now, the exponents, and you always start with whatever your first thing is here in your binomial, it gets that power. So this is going to be x cubed, and then I'll count down. And I'll end up with 0 always at the end. And then I'll do the same thing the other way. I'll put plus signs between each term to separate them. And this one is going to have a little bit more simplifying to do. So here we go. Everybody caught up here? Everybody's good? Easy process, easy. So now we're going to simplify. Anything to the 0 power is 1. So this first term is just x cubed. But now here, we have a 3x squared times a 2y. So that's going to be 6x squared y. Now this is where it really starts getting tricky if you're not careful. It's not tricky, you just have to pay attention. See this right here? That's not only a y squared, but that's also a 2 squared, 4. So this is 3x times 4y squared. You have to square the whole thing, the 2 and the y. So that term is going to be 12x y squared. And then how about on the end? What am I going to have down here?
2y to the third.
Okay, it's not 2y to the third, it's 8y to the third. Because when you cube, you have to cube everything. The 2 and the y. Just like here, we squared the 2. You got to cube it. So that last term is going to be 8y cubed. Okay? So the hardest part about that is probably the simplification. All right, here we go. See how far you can get with the next one. I know it's freezing in here, but we're not supposed to wear hoods in the building. I get it, it's cold, I know, but we're not supposed to wear them in the building. All right, so who started? Has anyone started? How did you start?
Did 1, 5, 10, 10, 5, 1.
This is the 5th row of the triangle. Would everybody agree? Did you write down that triangle? So you know the 5th row, we went to the 5th row because it's 5th power. Right? Okay, who did the next step? Anybody get the next step going yet? So next to everything, and this one's a little bit different, Leah, because it's a 2x and a negative y. This time it's a negative y. So I'm going to put a 2x and a negative y next to everything. Now, please don't think this is 2x minus y. It's not. It's 2x times negative y. How long do you have to keep your finger in that thing? All right, now what? Now we'll put our powers on. So remember, whatever the first one is, it gets this power to start. So 5, 4, 3, 2, 1, 0. And then 5, 4, 3, 2, 1, 0. All right, now we got to start simplifying. Is everybody good to this point? Anybody have a question so far? Everything looks good to here? All right, so now we're going to simplify. Remembering that anything to the 0 power is 1, and that 5 has to get applied to the 2 also. So 2 to the 5th, 32. X to the 5th is my first term. plus. Right, now be careful on this. You have a 5. What's this part right here? 2x to the 4th would be 16x to the 4th. And then times negative y. So this won't actually be a plus. I think this is going to be a minus. Because won't that be a negative? I'm multiplying. This is multiply. So negative 80 x to the 4th y. All right, take a second. Go ahead and work on this one. See if you can get that simplified. When you get something, shout it out, and we'll see if we agree.
20x cubed. I don't know. Don't you gotta go be negative 8x? Don't you gotta do 2?
Uh-huh. Yep, yep.
Negative. It would be 20. You gotta choose a 10. Negative 8.
Okay, well, you're gonna do 2 cubed first. Remember PEMDAS, you're gonna do the exponent first. So you're gonna get 8. But then yes, you have to multiply it by 10, so you're gonna get 80. But I'm thinking it's going to be positive. Because when you square a negative, doesn't it become positive? So that's a y squared and x cubed, and then you're right, that makes an 8. 2 cubed is 8, times 10 is 80. That's right, positive 80 x cubed y squared. Yep. All right, how about this one? Shout out an idea when you get that, the next one here. Negative 40x squared y cubed. Now, why negative? Because it's a negative cubed, and that's negative. Why 40? Because it's 2 squared times 10. What about the next one? Positive 10x y to the 4th. That's exactly right. This is 2x to the 1st, so it's just 5 times 2. It's a negative to an even power, a negative to the 4th power, so it's positive. When you raise a negative to a power, an odd number of negatives will be negative, and an even number of negatives is positive. So what's my last term?
Negative y to the 5th.
Negative y to the 5th. That's exactly right. Negative y to the 5th. Remember, the other part disappears because when you raise it to the 0, you get 1.
Well, our answers always be like the x's go like down and kind of watch forward and the y's go up.
Well, if the problem is in the order x, y, yeah, the first one goes down and the second one comes up. Always. And another thing, Princess, that's kind of a little built-in check. What do you get when you add these two together? What do you get when you add these two together? See that? So all of your terms, the power has to add up to this. Which it will if you just count right. But. Okay. That's not hard at all. Let's look at the next problem though, because it's sort of the same thing, but a little bit different. First of all, if you weren't already shivering because it's so cold in here, something in this problem should make you a little bit shivery. To the 11th. Why does it bother me a little bit that it's to the 11th power?
The triangle's so long.
The triangle's going to be huge, right? And can I just, like, if I need the 11th row, can I just jump to the 11th row? No, don't I have to go row by row by row by row to build that? That stinks. It's going to be huge. Luckily, there's a shortcut. The numbers in the rows of Pascal's triangle are the combination numbers. Here's what I mean. If we go to the, I'll just use the third row of the triangle. This number right here is really 3C3. And this one is 3C2, 3C1, 3C0. So if you typed it on your calculator, 3C2, it would say 3. And if you typed in 3C0, it would say 1. So the 11th row of numbers would be 11C11, 11C10, I'm just counting down, 11C9, and so on. Every single time, the rows of Pascal's triangle are the combination numbers. Start with whatever row you want. So if I'm doing the third row, it's 3C3. If I'm doing the 11th row, it's 11C11. And then I count down just like I did my exponents in the last problem. So this says, find the 5th term. I don't need the whole thing. I only want the 5th term. So the first term will have an 11C11, second term 11C10, third term, fourth term, fifth term. This is the number I want. So I'll go to my calculator, and 11C7 is 330. So the coefficient number, if I were to write out the whole row, the 5th number in that row is 330. Now think about this. Think about the problem we just did. If you wrote out the whole row, you'd have all these numbers, and then next to each of the numbers, wouldn't you put a 2x and a y? And then you'd put your powers on. And to put your powers on, you would take your first thing, 2x, and you would start with 11. So here, the power would be 11, 10, 9, 8, 7. Isn't that power going to be a 7 on that term? If I count down. What? The other one's going to be, it won't be 5, it will be 4. How do I know it will be 4? Because these have to add up to 11. Remember what I just talked to Princess about a minute ago? They all added up to 5 because we were doing a 5th expansion. All right, so where did this 330 come from? Let's make sure we know. 330 came from doing 11C, 11, 10, 9, 8, 7, and I just counted down to get the term that I wanted, which was the 5th term. So then next to the 330, I put the 2x and the y. And then how did I get the powers on? I counted down again. 11, 10, 9, 8, 7. And if that's a 7, that has to be a 4, because they have to add up to 11. So now, here we go. I got 330 times, all right, now that's 2 to the 7th, which I should know, but I forgot, 128, x to the 7th, y to the 4th. So 330 times 128, 42,240, x to the 7th, y to the 4th. That is your 3rd or 5th term. Right there's your 5th term. Okay, that's kind of cool. Let's see if we can figure out the next one. Oh, this one's a little bit tricky. This says, if we expand x minus y to the 10th, there's a term out there somewhere that's going to be x to the 4th, y to the 6th. Now, let's make sure everybody understands that. Look at some of those that we expanded all the way out earlier on the previous page. Every term had some kind of combination of x's and y's with differing powers. If I were going to expand this out all the way, which you can always do, but it just is extra work. If I were going to expand that out all the way, would you all agree that the first term would have an x to the 10th? And the next term, whatever else it has, it would have an x to the 9th? And an x to the 8th, and so on. So somewhere along the line, I'm going to get down to an x to the 4th. Would you agree? And of course, if the x is to the 4th, the y has to be to the 6th, because they got to add up to 10. Right? Now, the only thing I'm not sure about is, what is the number that's going to be hooked to that x to the 4th? Well, in the 10th row, I know the numbers are 10C10, 10C9, 10C8. Now, you don't have to write all these out, but I am, just for purposes of our conversation. So here are all the numbers in the 10th row. They're all the 10C numbers. So 10C10, 10C9, and so on. Now, the power, I got to get down to x to the 4th. That's the term I want. And I know right here it's going to be x to the 10th. 9, 8, 7, 6, 5, 4. Isn't this the coefficient that would be attached to the x to the 4th term? Yeah. So this is going to be 10C4. And yeah, I don't know what that is. What is it? 210. So that term is 210 x to the 4th, y to the 6th. So what's the coefficient? 210.
It's just 210.
Just 210, because it doesn't say find the term, it says what is the coefficient of that term. So the whole term is 210 x to the 4th, y to the 6th, but the coefficient is just the 210. All right, one more of those. Find the third term of the expansion, 2x plus 3y to the 5th. Now you actually have the 5th row of the triangle written down, so you could actually just use those numbers if you wanted to. But we also have now discussed that the 5th row would be 10C, not 10C, would be 5C5. The 5th row is 5C5, 5C4, and the third term is right here. That's the term I want. You could also 1, 5, 10, 10, 5, 1 is the 5th row. So this must be 10. 5C3 is 10. Doesn't matter how you get it. Get it from the triangle, get it from the C numbers. I don't care, it doesn't matter. So my coefficient is 10. That's the third number in the 5th row. I want the third term of the 5th expansion. So next to that 10, there's a 2x and a 3y. Next to all these numbers, there's a 2x and a 3y. But I only care about the third one in this problem. What are these powers gonna be on the third term? To the fifth?
Sarah?
Okay, now be careful. In the first term, the 2x would have a 5. But in the second term, the 2x would have a 4. And in the third term, it will have a 3. Remember how they count down? So this is going to be a 3, which is automatically going to make this a 2 because they have to add up to 5. Remember, kids, if we were writing out every single one of these, the first power on the 2x, right here in the beginning, would be 5. And then here it would be 4. And then here it would be 3. The term I want is 3. Okay, now, what's 2x cubed? 8x cubed. What's 3y squared? 9y squared. So now we're multiplying 10 times 8 times 9, which is 720, x to the third, y to the second. In the first few problems we did, we were doing the entire thing. We were simplifying every single term in the whole long line. In these problems, we're just focusing on one term. So we're doing the same kind of simplification, we're just doing it with one term. Okay? All right, I'm going to stop there. We will pick up there next time.